Okay, I will attempt to have a general solution to the first order Vlasov equation. So first thing first, we know that we first introduce the general averaging. Any quantity that is proportional to ikx minus I omega t will left with this is real space, this is guiding center space. Here is K perp, rho is general radii. So for our purpose, for most of the fusion devices, the J non K parallel, the K perp rho is roughly 0. Then we left us J naught is roughly 1. So we don't need to worry too much about general averaging. But as you can see, it's relatively simple. Whichever quantity is proportional to the ikx minus I omega t, we will just stick a J naught in it. J naught is the first kind of Bessel function. So yeah, that's the first things first. Second, without losing much generality, we could assume that the B naught is on z direction, and E perp is on y direction. As you can see, I mean, it's trivial. You can just rotate however you want. So it will be fine. And then now let's define the distribution function. Distribution function consists of non-perturbed Maxwellian. S stands for species, and adiabatic perturbed term, and non-adiabatic perturbed term. So just to keep in mind, or just a note for myself rather, the HS is guiding center distribution. So that's why you don't need to multiply J naught to that. It's already guiding center. And those two terms is perturbed term. We denote it as a delta F. So let's first get our Boltzmann equation going. I don't even do that. P stands for momentum. And just to be general, then we have our collisional term, collision operator. And if we assume that the mass won't change because we're dealing with, for atomic perspective, it is a fundamental particle. It's not, yeah, I won't go to those details. So then we will left with this. It'll be almost the same, but it's good to have that. So for velocity, we have parallel velocity. It's just move along the line of force, E cross P drift, and curvature drift. So first, let's study the electric field. Oh, shoot. Electric field, which can be expressed as del phi minus del A del T. We know if we assume every quantity is proportional to e to the I kx omega t, so we have negative I k phi plus I omega A parallel. A. For most general way of expressing it. But as we know, as we have first assumed that we only have y direction, then we have negative I k parallel z minus I k y phi y plus, if we assume that we only have a parallel as a perturbation, so we will only have a parallel z. That's one thing to keep in mind. And as for B, we have B naught plus del A parallel. If you go to the detail about it, we can just write it here, I guess. You switch talk. So we for A parallel only have Z component. So we have IKY a parallel x minus IKX a parallel y. So we are left with this nice expression. KY a parallel x minus IKX a parallel y. And you need to keep that in mind. That will become handy for the future. So after all that, let's try to study the drift velocity. So first start as E cross B drift. As we know that E is the first order. E is the first order, B is 0th order. So we will end up having, we need first order, so we will end up having E crossed by B naught. Because anything in this will become a second order. So then we have IK theta, so y cross z. This is z direction, as we know. Y cross z is x. So we have this. And plus, negative y. Oh, sorry. Yeah, that's the only term, I'm sorry. Yeah, that's the only term, both are z direction. So, sorry, checking. Yeah, and there it is. Here is our electric drift wave, E cross B drift wave, negative IKY phi C over B naught, x at x direction. Yes. And of course, again, feel free to pause at any time to capture all those detailed derivation. From Chen's book, we have the drift velocity. Big R stands for the major radius. If we consider the toke device. Oh, it will be good to mention that the Maxwellian will be proportional to e to the negative m v squared over 2t, so that we can use that for some calculation. So now, with all that in mind, I will erase those because we don't actually need those information. But maybe I will left our Boltzmann equation here. Right. So far we calculate the electric field, magnetic field, and the drift velocity. And now we can apply those quantities to our Vlasov equation. At first, let's try to study those various quantities. This part will be our note. So first, obviously, the Maxwellian is not time dependent. Second, then let's study V parallel dotted by cross F naught. So I guess it's only fair to show how to calculate del F. Because that is depend on temperature, density, velocity. So using chain rule, we know that we could do this. I'm using Einstein notation. So let's see about that. So first, we know that f is proportional to the exponential of m v squared over t. So that means if we do the derivative, then we have yes. And of course, this will just become del t. And this, what happened here is, density is defined as that. So you know that n is proportional to f. If not, then you have this. So we're missing one last puzzle piece for some reason. Oh, I'm sorry, because the f is also proportional to 1 over t 3/2. Then it's not just this. We'll also have 3/2 1 over t minus this plus. Yes, that's not. We put it all together. So we have -3/2 plus v squared 2v thermal. Sorry. Yes, so keep that in mind. So the on the chalkboard, that's great. So let's write it down, del n naught over n naught plus v squared 2t over del t n naught over t. There we go. The important part is that the direction of the gradient, temperature and the density gradient will be pointing at the radial direction. So let's study the V parallel N naught. Sorry, del F. So V parallel has a direction of B dotted by RC. The B, we got from here, negative K. We need to remind ourselves B is a Z direction, E Pervis is a Y direction. So we have R. So R is definitely perpendicular to Z direction. So we won't have any dot product with this. So we're left with I A parallel del F KY Z, sorry, not Z, X dot R minus KX Y dot R. There we go, and then we assume let's just leave it like that for now. Then V parallel del F naught is IA parallel V parallel B KYR X minus KX Y del F naught. Let's study the drift velocity. The drift velocity is, as you can see, it's right here. This has a direction that is parallel to the direction of C. Sorry, it's proportional cross B dotted by something with direction of R. Thus, vector identity. Then we have 0. Then the curvature drift dotted by the grad F give us 0. And let's study what does this give us. Sorry. So we have the F naught is proportional to the exponential of v squared over 2t. Good old thing, we have yes, just double checking. Those m cancels out. We only have the force due to electromagnetic field. So we have electric force plus the Lorentz force. Again, the vector identity v cross b here dotted v here will be 0. So Lorentz force will have no effect on this term of the equation. Then we're left with QE dot V over T F naught. So if we expand it further, forgive me, it's getting really hard. Yeah, if there's a negative sign, I apologize, because it's proportional to the exponential negative mv squared. So there's negative sign here. So if we expand it with a different velocity, v parallel plus VE negative IKY phi C over B naught x direction plus VD and again here is another, I mean I should not use this, you can just see that as E dot the VE is E cross B. So I ended up having an identity which is 0. So that will be 0. So we're left with negative Q T E parallel V parallel plus E perp VD. So we have negative Q over T E E parallel V parallel plus E perp VD. There we go. There we go. Thus, sorry, I should express E parallel and E perp in this equation as well to make it even more messy. Perp is here, negative I parallel phi. Perp is here. There's F naught, of course. And there we go. Really long, messy equation. I apologize. But we can apply some simplification. We assume we give some, not simplification, by just adding some different notation actually. Sorry, that's temperature gradient. Density gradient, same deal. And omega d. And most importantly, omega total. So we can simplify this quite a bit. Because remember del F is just like that. Then you can just use this expression. Then we ended up having something like this: del F equals to QB over KY CT omega star total F X. We assume that radial direction is X direction. then let's simplify this. This doesn't change. And this change to so you multiply this to here, you got, yeah, they're all parallel, ky, then ct ia parallel, v parallel, minus I phi c over t. Oh, there's a charge, of course. I was confused, the unit is not consistent. There we go. Omega star total. And then, now from here, we have omega d